200 millilitres, 10 volts AC, multimeter, and salt. So we're going to see how adding salt affects it. So let's get started. Right now, with tap water in the UK, we get 2.2, 2.3 milliamps flowing. So let's go ahead and add the first spoonful of salt. And we're going to see how much that affects it as we go. Here we go. So I'm going to switch the meter up a range just in case. In with the salt. There we go. So now we have about, 8-9 milliamps flowing. Let's give it a mix. 20. Okay, so let's turn it off and give it a good mix. Okay, going live. 100, 110, 112. That's a fair bit of current just to go through some water. There we go. So I have to go up a range once again. So we're going to go ahead and add the next thing of salt. Let's try that. Turn it off. Give it a mix. And turn it on. This time we're getting close to 200 milliamps now. We're getting 193, 194 milliamps. So as you can see, the more salt in the water, the more current there is flowing from one side to the other. To do this is actually quite a safe experiment. We're using a AC transformer in the safest way we can. So we're using 10 volts AC instead of mains just to be safe. And before we put the spoon in, every time we are turning it off. So let's add the next spoon. Spoon. Off. Give it a stir. And let's see what we get. On. Here we go. 315 milliamps flowing, so I'm noticing a bit of a pattern here. Every spoonful we put in, it goes up by about 100. So let's do that again with another spoonful. Here we go. I'm going to add quite a lot this time, so it's going to be a full spoonful this time. There's loads here. Right, so we're going to turn it off. We're going to give it a stir. And on. Here we go, 454 milliamps flowing from the transformer through the water to the other side of the secondary winding. So we're going to just go ahead and sprinkle lots in this time. I'm not even going to use a spoon. There we go. There's loads in there now. I don't think we're going to do any more. Power off, give it a mix. Power on. Oh, 650 milliamps. That's a lot of current going through that water. So 655 milliamps going through the water and back. As you can see, the water's actually changed colour now. I think it's making a slight noise. You probably can't hear it on the camera. Oh, never mind. We're just going to add loads. Like I said earlier, this is the safest way I can think of doing this. Not touching anything and turning it off between adjustments. We're going to try and get to an amp. An amp through water is pretty good in my opinion. You never get that much going. Right, I have to give it a stir. Power down. Mix. Power on. Oh, here we go. 954 milliamps. I think we need a bit more of the old salt. Just about run out of salt, actually. So hopefully we can get to an amp with whatever I can get out of this. Come on. Need to get to an amp, then I'll stop. Okay, that's the most I can get. 997, 980. 1 amp. There we go. 1 amp through water. There is 1 amp AC going through the water currently. It's a lot for water. Let's turn it off and give it a mix and see what we can get it to. And power on. There we go, 1.2 amps or near enough. So I think it's time to end the experiment here. If you are going to try this at home, make sure you do it in the safest way possible with no exposed connections. The way I've done this is with a mains transformer, stepping it down to about 10 AC, with an elastic band holding 2 bent wires in the water, with the multimeter obviously in series. Okay, so thank you for watching this video. Stay around for the next video where we'll be doing some more fun experiments. Thanks.